Hey kids, welcome to the final installment of Miss Shivik's Fun with Fractions. I know you're really sad for this unit to be over. Let's get started. So today, I just wanted to talk about the two algorithms we've been using to solve fraction division problems efficiently, right? Because drawing models is great for understanding what it is that we're actually doing, but they're not the most efficient way to solve a problem. So let's look at the two algorithms that we've talked about. Okay, the first problem I'm going to give you is 7/8 divided by 1/4. Or how many groups of 1/4 fit into 7/8? So, little alarm bells should be ringing off in your head right now because 8 and 4 are two very closely related numbers because 8 is a multiple of 4. So you should be thinking, you know what, I'm going to use the common denominator method of solving this problem for this problem because it's a really easy one to do. So first thing I need to do is change both of my numbers to have a common denominator of 8. Nicely, 8 already exists in the first one, so we can keep 7/8 as 7/8. And then we have to change 1/4 to a fraction out of 8. So I'm just going to write an equivalent fraction up here. And if I want to change to 4ths to 8, I know I need to multiply the denominator by 2. And whatever I do to the bottom number, I have to do to the top number. So I get 2/8. So I'm going to rewrite my problem of 7/8 divided by 2/8 because 2/8 is equivalent to 1/4. Now I can go ahead and simply divide, right? 7 divided by 2 is 7 halves, or 7 divided by 2, which I can write that way. 8 divided by 8 is 1. Now, since I've got this number, 7 halves divided by 1, it's just going to be 7 halves, so I can pretty much get rid of the 1 and say that my answer is 7 halves. If I want to rewrite that as a mixed number from an improper fraction, I ask myself, okay, this is a division, 7 divided by 2. How many groups of 2, how many times can 2 fit into 7? Can fit in 3 times, which would get us up to 6. If I tried to fit in 2 again, only 1 out of the 2 would fit in. So I've got 3.5. So that's the basics of what you do with the first algorithm. You change to a common denominator. You divide the numerators. The denominators, if you divide them, they're always going to become 1, which we can then ignore. And just look at what we have on the top, which is 7 halves. And if need be, we can change that to a mixed number. So why does this actually work? Let's look at why this actually works, because that's important. It's one thing to know a rule, but understanding why it works is important. And for that, we can use our model, right? If I build 7/8, right? Okay, there's 2. Okay, I don't want this one on the end. Here's my 7/8. And then I want to build a 4th. Well, we already decided what is a 4th out of 8s. It's 2/8. There's a 4th because that would fit in 1, 2, 3, 4 times. Right? Now I've got the same size pieces. So that's the key to this algorithm, is that the pieces have to be the same size. As soon as I see that the pieces are the same size, these are 7 identical things and 2 identical things, right? 1, 2, 3, 4, 5, 6, 7, and 1, 2. I simply am finding out what 7 divided by 2 is, right? This is 7, this is 2. I want to know how many times this fits into this, which is the definition of 7 divided by 2, right? That's exactly what we have. So this algorithm works when and if we have the same size pieces, because we just get a simple, straightforward whole number division problem. 7 of these things, 2 of these things, I want to know how many times these 2 things fit into those 7 things. And because they're the same size, I can do that easily. All right, let's look at the second algorithm, which is multiplying by the reciprocal. So I'm going to give the problem to start 3 divided by 1/4. Or how many times does 1/4 fit into 3? So, okay, well, I'm going to multiply by the reciprocal. So I'm going to change the second number to its reciprocal, which is 4/1. I'm going to multiply. I'm going to put that over 1. What do I get? 3 times 4 is 12. 1 times 1 is 1. My answer is 12. So 1/4 fits into 3 12 times. Now again, we want to look at why does this actually work? That's the important thing. So I'm going to draw my model and draw 3 holes. 1, 2, 3. So there's 3 holes. Because we're dealing with fourths, I'm going to split them into fourths. And then I want to see how many times 1/4 fits into these 3 holes. And I can count, and I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Voila, 12, right? But why are we doing this? Why are we multiplying by 4 right there? Well, let's look at how many times 1/4 fits into one hole. Fits in 1, 2, 3, 4. How many times does it fit just into the second hole? Oh, look, another 1, 2, 3, 4 times. How many times does it fit just into the third hole? 1, 2, 3, 4. So what do I have here? I have 1, 2, 3 groups of 4. So 3 groups of 4, and that's 3 times 4. So a reciprocal tells us, right, the reciprocal of 1/4 is 4/1. The reciprocal tells us how many times our fraction, in this case 1/4, how many times our fraction fits into one hole. In this case, 1/4 fits into one hole 4 times. Once we know how many times it fits into one hole, we can figure out how many times it fits into anything simply by multiplying. So if I change the problem to be 5 divided by 1/4, same thing, I just have to add 2 more holes, right? 1, 2, it's going to fit into this hole 4 times, and this hole 4 times. Now I've got 5 groups of 4, so I can do 5 times 4/1, which is 20/1, or 20. So last little important piece, a couple little things I've noticed when people are doing this algorithm method, is they get tripped up if we have a mixed number. So say I had 5 divided by 1 2/3. They go, all right, okay, well that'd be 5 divided by 5/3, right? I've already flipped it, so it's 5 times 5/3. No, you have not flipped it. All you have done is changed 1 2/3 to 5/3. This is the same number. You still have to go ahead and flip 5/3 to 3/5 if you're multiplying. So 5/1, we get 15/5, or 3. Okay, one last thing before we go. Wouldn't want to make this a short video. I'm going to look at the problem 3 divided by 2/3. Okay. Now, up until now, we've been looking at fractions that have a 1 in the numerator. And so it's really easy to say, oh, well, 1/4 fits into 1 4 times because there's 4/4 in one hole. Or 1/5 fits into 1 5 times because there's 5/5 in one hole. What about 2/3? 2/3 doesn't go into 1 a whole number of times. But we can still look to see how many times it does fit in to one hole. Okay, there's my 3 holes. I'm going to split them into thirds because I know I'm dealing with thirds. Right? So 2/3 would be represented by 2 of those. So I'm just looking at how many times this 2/3, for right now, I'm just looking at how many times this 2/3 fits into that one hole, because that tells me the reciprocal, right? So this fits in once, right? There's our once. Now if I tried to fit it in here, again, how many of those 2 would fit in? Well, only 1 out of the 2 would fit in. So how many times does 2/3 fit into 1? It fits in 1.5 times. Well, what's the reciprocal of 2/3? Let's look. We have 3 divided by 2/3. If we change that and multiply by the reciprocal, we get 3/1 times 3/2. What's 3/2? It's the same as 1 1/2. 1 1/2 is 3 halves. So just because we don't have a 1 in the numerator doesn't mean we can't find the reciprocal. We still find it simply by flipping the number over. Because we've shown here that 2/3 fits into 1 1.5 times. As soon as I know how many times it fits into 1, same things apply.